Hello everybody. Today we're going to be talking to Dr. J. Patrick Kennedy. He's the founder and CEO of OSIsoft. Good morning, Pat.
Good morning.
Great. And if you don't mind, can you just introduce yourself and tell us what you do at OSIsoft?
Well, as you just stated, my name is Pat Kennedy, and I'm the CEO and founder of OSIsoft. I started the company 40 years ago in one person, who was me, and now we're up to 1,500 people and doing very well, thank you.
Okay. So Pat, can you just explain to us, why do you think people buy Pi?
Well, the reason they buy it is that it's not us or it's not the company. They're after the data. And one of the issues is that when you're using data where you might be in an environment where you could put people or equipment in jeopardy, then that has to be rock solid, has to be very stable, has to have already been done 1,000 times. It's not really the same as buying an application that cuts paychecks or something like this. So one of the things that we have to do when we talk to people about using the data is, first of all, we have to show them, and this is by example, it's not just what we say, we have to show them that the data is as reliable as they need for operational decisions. And I think if you think about it, if you think of the people we're talking to, say, engineers that have evolved out of the plant and engineers that are now running their operation, people that have seen both the good and the bad about the industrial processes. If they can convince themselves that you can reliably show them the data from their own facilities, they don't need us to tell them how much it's worth. So to have a consultant come in and say, oh yes, this data will save you 10% of your energy. I've seen plant managers laugh and say the next person that tells me I can save 10% of my energy is going to turn me into a power plant because I'm generating energy. And they don't really need that. What they need to know is that it's a professional, reliable system. And so a lot of what we talk about is how others are using it. We open up our installed base for the people that give us permission. We allow them to talk to each other. We have users conferences that as big as 2,500 users get together and they discuss how they're making money off these data. And we're simply the agent to do that. We're not really the ones that created the value. They create the value. We're just showing them how to grab more of it.
Okay. And now along the way, I think there's been an emphasis on following what customers want. Was there any time we ever did something that customers wanted that ended up going in the wrong direction for us and we had to correct?
Anything you could do wrong in this business, we've done. Also, a lot of things you can do right. But how you respond to doing something wrong is what really matters. Yes, we have gone down some routes that we shouldn't have gone down. But what we do is that we recognize that we're the ones that change, we're the ones that back up, and we try to make sure that we protect our customers from those problems, and you end up so that those are eliminated from the field. And I could give you some examples. One example, this is a very techy example, but one example was the scripting that goes on within software, which becomes very important because that's the way you manipulate the object on the screen. Initially, when people wanted to put in scripting, there were a couple of companies that made a scripting language, and we fully embedded that into our system. But then what happened is that Microsoft decided to release VBA to the world. And we said, oh, well, we're wrong. We have to back up. And so we basically redid that whole application, took out the proprietary scripting language, we put in VBA so people could enjoy the benefits of a very high volume, well-supported system. And there's other examples where we at one time we thought we were going to go into the application business, and we found out that it's a totally different business than the infrastructure business, and we shouldn't be in it. So we would either spin it off, sell it to somebody else, do something to minimize any problems our customers might have because of our mistake. But on the whole, we've made some pretty good decisions. And I think one of the reasons is that we are experienced in this area. So when we float around and see these thousands of customers and what they're doing, and we publish papers and they publish papers, we get a really good feel for what works and what doesn't work. And I think being good observers has been one of our strengths over time. What we've done to enhance our odds of making the right decisions is that we hire people with good, solid engineering degrees, technical degrees, so that they can understand what customers are doing with our software. We keep a very open environment. We have and sponsor both user groups and seminars so we can discuss and we can hear what they're doing. We can make decisions on what to do next. And then we try to make sure that we build according to some tenets that ensure that the customer gets the most value he can out of our work. For example, we make every attempt we can never to leave a customer behind. Nothing in this world is worse than if you buy something that's brand new and then the vendor changes to a completely new incompatible version. It's just doesn't make any sense from their point of view. It doesn't make any sense from our point of view. I think also one of the things we've always done, and this may sound funny, but we've always made money. And I think that's very important. I think a lot of small companies, they do the wrong things because they don't have enough money to do the right things. So we funded with real estate. We didn't use people that were looking every month on how much money we made. We built a business that was on good solid economic grounds, and we put all that money back into what we did. And so that was really the business plan in a thumbnail. And it's really a pretty simple plan. There's really no downside in supporting your existing customers.
Okay. So have we ever looked at ourselves the way, well, there's a story you like to tell about the railroad companies, not really understanding that they were in the people moving business. And they could have exploited commercial aviation. I love that story because obviously it's just so engaging, but what's the lesson to that for us? What business are we in? I mean, currently we make software. We make a software of a certain type, and people do real-time data. They optimize operations with it. Is that what business we're in? Operational optimization. But how would you describe our business?
No, actually, we're not. We're not in the software business. We're in the business of bringing the information people need to do their job. The actual story, by the way, wasn't mine. I plagiarized it. The observation was that the train companies never knew they were in the transportation business. They thought they were in the train business. Think about this. They had the downtown locations. They had the feeder routes. They had the right-of-ways in and out. They could have owned the airline business, but they said they're in the train business. These airlines are not going to make it. So we're in the data business, and I think that what we've always done, we've tried to stay ahead of our customers, which is really hard to do because no matter what you build, they want more. And I don't blame them because of the immense value in the data coming out of these facilities. But let me give you one example. We heard a whole raft of pundits that talked about big data, and big data, they talked about having millions of sensors. Well, let me up that a couple, maybe 4 or 5 orders of magnitude. If you looked at the software it takes to monitor and manage the power grid, you're looking at, because power, remember, communicates at the speed of light, you're looking at 1 trillion points. You're looking at every device that is either a load or a generation on it. If you're looking at software that manages the transportation business, you're looking at the same thing. And now if you look at something like a smart city, you're looking at the combination of those two. So the job out there is really much bigger than we have figured out at this point. And so we have a lot yet to do. But mainly we know how to do it because we've come this far. But now what we have to do is we have to see how we get bigger yet.
Okay. OSIsoft started as a control engineering firm, right? Can you go ahead and describe that?
Well, I was actually selling for an instrument company, and we were selling process computers that were used for advanced controls. And as part of one of those sales cycles, I developed some control algorithms that were put on a unit in a refinery that makes unleaded gasoline. And in the 1980s, that was a big deal. So when I broke off to start my own company, one always goes to do what they think that they should do, what's familiar to them, and they have experience. So I had this vision of starting a company that did advanced controls. I found out that it's a lot of work, a lot of travel, and there's real issues about having such a company.
Okay. And now, if I understand correctly, at some point we needed a tool to kind of verify what was going on was actually doing good in the field. And that's the birth of what later became the Pi system. Can you tell that story?
Well, sure, but let me take you back to that time. Mm-hmm. The computers that sat in heavy industry, like refineries and paper mills, tended to be departmental computers, which were primarily doing IT things or business things. And there were a few versions that had sensor-based data collection, but they weren't very common. And that was the environment we were selling into. So when we tried to go out and do our advanced controls, we found that there was quite a paucity of data, because the way you build advanced controls is that you build them, but the most important thing is that they remain robust under unusual events. And since operators don't allow you to create unusual events, what you need to do is to put them in and put in data collection and then go away and leave them alone until either the weather or some failure creates an unusual event, and then observe it and what it does during the unusual event. And since we didn't have that information, we built a system in order to do that data collection on the brand new idea, which was called digital instrumentation, sort of the first of the wave of digitization that went on in the industrial world.
Okay. And at some point, you recognized that the value that storing that data that was now available to you because of this digitization, that was actually of tremendous value to customers. Can you describe, I mean, was there an aha moment?
Well, there actually is. And the aha moment comes when you realize that you don't really know as much as the user does. And that came when I went up and tried to hire a gentleman to come into the company because we were growing, and he was from the paper industry. And he said, you know, that's very nice software. I don't want to work for you, but I'll take a package and we'll put it in a paper mill. And I said, no, you can't do that. It's built for refineries. He said, yes, we can. And that's when I started to realize that what we had built could go from industry to industry and could actually be a standalone package that could be sold.
Okay, well, that's cool. So what was the first operating system you worked on, and how long did you work with that, and what made you move?
Oh my goodness. The first operating system was Hewlett-Packard RTE-A, which was a multi-user, multitasking operating system that was built for the last of the 16-bit generation of mini computers. And it was very nice, very robust. But then the VAX came out, which was much more acceptable by the industry. And so we switched over to using the VAX running the VMS operating system. So we missed the whole RSX operating system, which was not nearly as developer friendly as the VAX VMS system was.
Okay. And you stuck with VMS for many years. You eventually moved off to something else. What was next?
Well, we moved the way the industry did. We moved from the VAX VMS, and then we moved at the server level. We moved to the NT because at the time we were starting to develop client server technology as well. But at the same time we did that, we moved to several more Unix-based systems. So for a while, we built systems on multiple platforms, being VMS and HPUX from Hewlett-Packard, AIX from IBM, and Digital Unix from DEC.
Okay. And now jumping forward with an NT and a Unix platform, next big milestone was we went to client server. Can you explain kind of what the story is how we decided to go to client server?
Again, the users came in and explained that to us, that what they really wanted is they wanted to use their PCs, which were becoming common, as the human interface, and they didn't want to go to a terminal that came off the VAX. So one thing I hope we're good at is listening, and we shifted over to client server technology, but that was during the time we had all these versions. It was not really a separate evolution. Mm-hmm. And then at the server level, we finally decided that it really wasn't worthwhile to build all these versions of the system. It was forcing us to use lowest common denominator development methods, and they weren't selling. The last year we sold multiple versions. There were 0 sales of the AIX system.
Okay. So, and at some point you decided to implement something that we hadn't had up to that point, which was a kind of a structure that now we know as asset framework. Can you describe what the need for that was? What were customers telling us? Why did we develop that?
There's a technology in software called shaping, and we can all see this if you look at assets, or if you look at anything, any objects, anything. It's better expressed to people as something like a tree control, and that's what they call shaping. In order to shape the data, you need to have and carry with the system some information as to what that shape is. What is a pump? When you click on a pump, what do you see? And that became and evolved to the application framework.
So why did you build those tools?
Well, the thing about the shaping is that that's really something people need to do. And we are observers of our customers. And one thing our customers were doing is that they were using relational databases, they were using spreadsheets, they were using file methods. They were trying to do this work themselves. And once we see it happening many times, we have to stop and consider what our role is in there. And from that, we decided that this was the appropriate tool. And we had then constructed this asset framework. I must say, it wasn't my idea. I'm more of a user than I am in designer, but when it came out, I immediately saw the value of doing it.
Okay. And customers, what was the customer response?
Slow. It is an additional step, because now they have to basically build up these metadata and make sure that they can be used. And on our side, we had to modify our application so that we could actually use the shaping data ourselves. For example, if you're doing a calculation, if you can use the AF in order to identify the calculation, you can write it one time and apply it to all the pumps in the system. And so we had to modify a lot of our applications as well. But slowly we evolved until we had a robust system that was relatively easy to set up via templates that allowed people to have a place to store this metadata.
Okay. And other milestones along the way. At some point, we developed an application that would allow people to watch this or look at this data on their web pages. Can you describe the evolution of that?
Well, the viewing and the interaction with people has actually been a big deal for us for a long time. When we moved to the PC as a interface to people, we also got access to things like spreadsheets. So by putting data into a spreadsheet, then all users know how to work with spreadsheets. And so they were able to manipulate the information themselves. And this was always one of the very favorite things about the operations people, is that they wanted to be able to build up the use of the data themselves without having to have a project and a fixed system. The other thing is we noticed that there were several types of display mechanisms that were dominant over the rest of them. In particular, the ability to trend data and to trend those data on top of graphical interfaces. And it may sound strange, but in those days, it was uncommon to find the ability to trend data and the ability to look at a mimic at the same time. These were usually two separate applications. So we put those together and had just one operator interface.
Okay. Now, I've heard you say that the power of a smart engineer with a spreadsheet looking at his data, that the power of that is just far and above larger applications. What do you mean by that?
Well, let me change your words a little bit first. The value of what we do is in the data. If you could see in some mechanism, whatever that mechanism was, if you could see something coming at you, you know to avoid it. If you can see that when you operate in a certain way, you do better than when you don't, then that's worth something to you. So keeping in mind that the value is in the data, not necessarily in the mechanism we use to display it, then our role is to put it in easy to use things that people are trained on using. And Microsoft did the world a tremendous favor about that time, is that they taught maybe 1 billion people how to use spreadsheets. And so by putting the data into spreadsheets, we get all the benefits of that training, and we never had to do anything, just get the data to them.
The next step was to go outside of the company that's generating the data, and it's what you call a community system. Can you describe what that step was like?
The community system is actually relatively new. What's happening today is that these systems are growing, and they're growing very, very large. We hear about things like IoT, and we hear about things like Industry 4.0, but these represent the digitization of the entire industrial landscape. Once something is digital, you can communicate with it. You can show it here, you can show it everywhere. And one thing to remember is that now you have to also take care on who owns the data. You can't just let everybody see everybody's data. And so we have what we see now, community applications coming, and these would be applications where many people have data, some of which is private, some of which is their own, but together these data actually work for the common good. And a good example of that is the distributed energy resources, where everybody puts solar on their roof, but the person who owns the roof owns the data, but that information is critical to the power company on how to balance the power. One other thing I'd like to say about data is that data is a very unique resource. In most resource critical areas, somebody consumes data, or somebody consumes a resource and it's gone. With data, the more people that consume the same data, the more valuable it becomes.
Okay. One last question, and it's kind of personal. What gives you satisfaction?
78. You probably want a different answer than that. Well, I made it this far. Um, so what gives me satisfaction, when I go to our own user conferences and I hear people, ordinary people that have gotten so much value out of our work, I find that immensely satisfying. When I am on any kind of a sales or discussion or briefing, most times I don't even know what we're charging. To me, it's not germane. What's really germane is that we're creating value. My friend from Germany used to say, if you want $1, you got to earn 10 because you don't get to keep all that you make. So our job is to look and see where the value lies and apply our efforts to getting that value for our customers with the hope that they'll share a little bit of that with us. But that's really where I get satisfaction, is when we actually succeed in doing that and move these customers, some of which are really very conservative, but move them further along on their use of technology to win over their competitors.
Okay, right. Well, I springing this on you, but we do a lightning round at the end of all these interviews. So are you up for doing a quick lightning round of questions?
Shoot.
Great. Is it true you don't have a high school diploma?
I do not. I think they may have given me one after I left, but I actually walked out several days before graduation.
Okay.
I walked out several days before graduation and went down to my summer job. And I'm going to really date myself. The reason I walked out is that they kicked me out for wearing shorts. Okay. But I have to also say, the day I got kicked out of high school, I was a sophomore in college.
Oh, in terms of credit hours, or?
No, I was actually a sophomore in college.
Okay, didn't know that. Okay, what's the first computer you ever used?
I had a what do they call it, a Zip 90 or something. It was a Z80 on a board you had to put together yourself. It was barbaric. That's the first one I had personally. The first one I really used was an IBM 1620 Model 2, and I worked for a company, an oil company, and nobody knew how to run it. So I had a summer job down there, so I had my own personal computer that literally filled the entire room. And then if somebody wanted to use it, I would get off, and then an hour later I would have it back.
Great. So do you have a memento from your days in operations, like a broken valve or a melted pipe or something like that?
No, but I have a funny story that goes with that.
Sure.
And that is that what happens is that, operations and IT, they're always at each other's throats. And so I observed once the operations guy would take an IT guy around, and they would show him these valves running high pressure steam, and everything is hissing and everything's noisy. And they would tell him, look, the last time somebody was out here, a valve stem let loose and went right through their head. And they would go away and they would never come back to the plant floor. However, the funny thing is that same engineer might need some data. They might need some help on how to get that information and some reporting. And they would go up to the ivory tower, and the IT guy would do exactly the same thing, except it wasn't a valve stem. It was something dastardly that happened to them in the computer business.
Okay, great.
So I've always said that you must be able to have operations and IT working in the same direction. The companies that can do that are going to win over the companies that don't.
Right. Well, thank you so much, Pat. Thanks for talking about the last 40 years. We're going to have you back to talk about the next 40 years presently. In the meantime, is there anything I wasn't smart enough to ask you? What did you want to say that we didn't have a chance to talk about today? About the last 40 years.
Can I have that as multiple choice?
Sure. Okay.
I mean, there's a lot to what we've done over time that really is worthy of talking about. Not necessarily because we're right, they're wrong, we're great, and everybody else is bad. It's just that you gain a lot of experience by listening to what other people do. That's sort of the whole nature of our evolution of learning. And I like to be as open as we can. I hope it's been useful and entertaining for people, but we have tremendous amounts of experience because we move around in these heavy industries and we see things, we understand things, we try to help here, and we try to then make sure that we take that and take it back, lessons learned, into what we produce.
Right. Okay. Thanks again. Dr. J. Patrick Kennedy, founder and CEO of OSIsoft. Thanks so much for being our guest.
Thank you very much.